Let's work on using some of the properties of exponents that we know to simplify expressions that have fractions in the exponents. For b to the 1/3 times b raised to the 5/3, here we have two exponential expressions multiplied together that have the same base. We know that what we need to do is add the exponents, b raised to the 1/3 plus 5/3. 1/3 plus 5/3 is 6/3. And 6/3, 6 divided by 3 is 2. So our final answer here would be b squared. If we look at 9 to the 2/5 divided by 9 to the 12/5, when you're dividing, you subtract the smaller exponent away from the larger exponent. Subtracting 2/5 from 12/5, we're left with 9 to the 10/5 in the denominator. And we would have a 1 on the top. 10/5, 10 divided by 5 is the same as 2. So we have 1 over 9 squared. 9 squared is 81. So 1 over 81 would be our answer. Looking at our next problem, here we have 3x to the negative 2/3, all that raised to the third, over x squared. Let's start by taking both parts of the interior of the parentheses on top and raising them to the third. 3 raised to the third, 3 times 3 times 3 is 27. For x to the negative 2/3 raised to the third, we take the exponent on the outside and multiply it by the exponent on the inside. Negative 2/3 times 3 is negative 2. So at this point we have 27x to the negative 2 over x squared. We'll leave the 27 where it is, but the x to the negative 2, we move it to the denominator and make its exponent positive. So that now in our denominator we have x squared times x squared. We add those exponents and the result would be 27 over x to the 4th. If you would like to try these next 3 problems on your own, pause the video now and resume when you're ready to see the solutions. For x to the 1/3 times x to the 1/4, we need to add our exponents. So we'll have x raised to the 1/3 plus 1/4. Now we need to get a common denominator to be able to add our fractions. A common denominator for 3 and 4 would be 12. We multiply the top and bottom of 1/3 by 4, making that 4/12. Multiply the top and bottom of 1/4 by 3, we would have 3/12. 4/12 plus 3/12 is 7/12. So our answer here is x raised to the 7/12. This is completely correct. If you were asked to write this using radical notation, you could, where it would be the 12th root of x to the 7th. Next, y to the negative 3/10 times y to the 6/10. This is the same as the previous problem. Multiplying two exponential expressions together with the same base, we add the exponents. In this case, they already have the same denominator. So we just calculate negative 3/10 plus 6/10, and our answer is y to the 3/10. And this is a perfectly good answer. If you were asked to write it in radical notation, you could, as the 10th root of y to the 3rd. Let's look at this next problem. Here, 81 b to the 6th raised to the 1/2 over 27 b to the 12th raised to the 2/3. So here, I'm going to write this out in several steps, where on the top part, we're going to raise each part to the 1/2. 81 to the 1/2, b to the 6th to the 1/2. In the denominator, we raise each part to the 2/3. 27 raised to the 2/3, b to the 12th raised to the 2/3. For 81 to the 1/2, that's the same as the square root of 81, which gives us 9. For b to the 6th raised to the 1/2, multiply the outside exponent by the inside exponent. 1/2 times 6 is 3, so we have b to the 3rd. For 27 raised to the 2/3, we would have the cube root of 27 squared. 27 squared is 729. The cube root of 729 is 9. For b to the 12th raised to the 2/3, multiply the outside exponent by the inside exponent. 2/3 times 12 gives us b raised to the 8th. Now in this case, the 9 on top and the 9 on the bottom will cancel each other out completely. B to the 3rd divided by b to the 8th. We subtract the smaller exponent from the larger exponent, giving us b to the 5th in the denominator, and we would put a 1 on the top.